All right, so before we look at example 22, we can just discuss the properties of y is equal to a to the x. Now, the graph to the right can help us to discuss these properties. Now, for this type of graph, a is greater than 1. So a is a positive number and it is greater than 1. So first of all, the domain of a to the x is x is an element of a set of real numbers. So the domain for a to the x are all real numbers. In other words, for every real number, you can get a value for a to the x. Sorry, for every real number x, you can get a value for a to the x where a is what? Greater than 1. And the range would be your corresponding y values. The range is y is greater than 0, and you all can see that the graph does not fall below y is equal to 0. The graph does not cut the x-axis. It approaches the x-axis, but it doesn't cut the x-axis. So y is equal to 0 is a horizontal asymptote as x approaches minus infinity. A to the x is an increasing function and it is 1 to 1. All right, so for every value of x, there's a unique value of y. For every value of x, there's only one value of y. The graph of y is smooth and continuous. Those are the properties of y is equal to a to the x, where a is greater than 1, a positive number greater than 1. All right, so next we want to sketch the graph of a. We're going to on the same graph sheet. Now, first of all, we just discussed this graph, so we can make a general sketch of it. So I join up my axes. It's my y-axis. My x-axis. All right, so this time around, I am not drawing up a table of values. I'm just doing my little sketch. So this is y is equal to 2 to the x. Of course, the value here is going to be 1 because the y-axis is the line x is equal to 0. And when x is equal to 0, you're going to get y is equal to 2 to the 0. And 2 to the 0 is 1. All right. Next, we're asked to draw the graph of y is equal to 2 to the x plus 1. Now, that graph is actually the same as this graph. The only difference is that the graph is going to go up 1 unit. So if the graph is going to move up 1 unit, this probably should have been a broken line, but so this is the line y is equal to 1. And I'm drawing a sketch of y is equal to 2 to the x plus 1. And I think I was saying to you, it essentially is the same graph as this one, except for the fact, all right, so my sketch is not exactly perfect. I'll try again. All right, essentially, so this is the graph of y is equal to 2 to the x plus 1. So essentially, it is the same graph, except for the fact that for y is equal to 2 to the x, the horizontal asymptote is the x-axis. For y, so for y is equal to 2 to the x plus 1, all I've done is literally, I just pushed the graph up 1 unit. So to get the graph of y is equal to 2 to the x plus 1, it is the graph of the what? It is the graph of y is equal to 2 to the x that is what translated 1 unit vertically upwards. In other words, I just push the graph 1 unit vertically upwards. Now, by pushing the graph 1 unit upwards, I've also pushed the what? Horizontal asymptote 1 unit upward. The horizontal asymptote was the x-axis, which is the line y is equal to 0. And by pushing it up now 1 unit vertically upwards, I've now made the horizontal asymptote y is equal to 1. Now, the function y is equal to 2 to the x plus 1 never, ever, ever falls below what? Y is equal to 1. So the minimum value, so the range for y is equal to 2 to the x plus 1 is y is greater than 1. The graph never cuts the line, y is equal to 1, and the range, the domain, it remains what? X is an element of the set of real numbers, but the range changes to y is greater than 1. All right, so for example 23, we're asked to sketch the graph of y is equal to 2 to the minus x. To get an appreciation of this, I guess we could have done a quick table of values minus values of x let's go back to blue. All right, so we select some values of x, minus 3, minus 2, minus 1, 0, 1, 2, 3. And then now y, which is equal to 2 to the x. So, sorry, it's not 2 to the x, it's 2 to the minus x. So minus would be plus. So this would actually be 2 to the third, which is 8. This would be 2 to the minus 2, which is 2 squared, which is 4. This would be 2 to the minus 1, which is 2 to the 1, which is 2. Well, this is 2 to the minus 0, which is just 2 to the 0, which is 1. This would be 2 to the minus 1, which is a half. This is 2 to the minus 2, which is a quarter. And this is 2 to the minus 3, which would be 1 over 8. All right, and so the idea is over the negative side of the graph is high, and as you come over the positive side, the graph becomes low. So it's similar to y is equal to 2 to the x, except for it's almost like you are reflected it in the y-axis. So a sketch of this would probably look something like this. All right, let's go again. Of course, here is 1. This is my y-axis, my x-axis, and this is the graph of y is equal to 2 to the x. It's a sketch. Sorry, not 2 to the x, 2 to the minus x. So this now is different from, would be different from y is equal to 2 to the positive x. So y is equal to 2 to the positive x is like this. Sorry, let's try. Yeah, it will be like something like this. And so this would be y is equal to 2 to the positive x, and y is equal to 2 to the minus x would basically come from the other direction. All right. Now, properties. First of all right, so this is not it. All right, so that's what the graph would look like. So we need to have an appreciation if we are sketching y is equal to a to the x. How would, where a is a positive real number greater than 1, how would the graph differ if x is negative or if x is positive? So that's what we'd get from this activity.